Welcome to the Q&A session 8 from the playlist of properties of matter. The topic for the today's session is the calculation of the work done in stretching a wire. And this session is in continuation of the session number 7, in which we have studied about the work done in stretching a wire. So the work done in stretching a wire, as we have learned in the previous session, that is in the session number 7, is equal to 1 by 2 into the stretching force multiplied by the elongation of the wire. So this was the formula which we have learned in the previous session, and from this formula work done is equal to 1 by 2 into stretching force. Now stretching force can be written as y into A into delta L divided by L, and elongation is delta L. Now this the stretching force is equal to y into A into delta L by L, and this has been substituted from the equation, that is Young's modulus is equal to F into L divided by A into delta L. Here Y is the Young's modulus of the material, and here F is the stretching force, L is the original length of the wire in this case, divided by the area of cross section into delta L, where delta L is the elongation. So by using this formula, I have substituted the value of F in this equation, that is in place of stretching force. So by substituting the value of stretching force as y A delta L by L, we have got this equation, and this can be written as 1 by 2 into y A delta L square divided by L. So this is the equation of the work done in stretching a wire. So in the question here, it is given that the work done in stretching a wire by 1 mm is 1 joule. The work done in stretching another wire by 1 mm of the same material, having double the radius and half the length of this original wire is. So there are 4 options here, and we have to find the correct one. So the work done in stretching this wire, that is the first wire, that is where the work done is equal to 1 joule. So in the first case, the work done is equal to 1 joule, and this is equal to 1 by 2 into y is the Young's modulus, A is the area of cross section, delta L is the elongation of the wire, divided by L, which is the original length of the wire. So this is the first equation. Now in the second case, we have to find the work done. So in the second case, the material of the wire is the same. However, the radius is double and the length is half of the original wire. So in the second case, the work done will be equal to 1 by 2 into y, that is Young's modulus, will remain the same because the material of both the wires is the same, multiplied by the area of cross section. Now here delta L will also remain the same, because here we have to calculate the work done in stretching the wire by 1 mm. So that the delta L in the second case will remain the same, and here in the second case the length of the wire is reduced by half. So this here the area of cross section in the second case will be, so this equation can be written as 1 by 2 into y. Now in the second case, the area of cross section will be equal to pi r square. Now here r, let us say the radius of the first wire is r. So in the second case, the radius is double. That is, in the second wire the radius is double. So the area of cross section will be equal to pi r square, that is 4r square. So it will be 4 r square delta L is the elongation which is the same in both the wires, divided by L by 2. Now in the first case, so in the first wire, when the work done is equal to 1 joule, the area of cross section will be equal to pi r square, where r is the radius of it. So this will be equal to pi r square delta L whole square divided by L. So we have got two equations, that is one is equal to 1 by 2 into y into pi r square into delta L whole square divided by L, and we have got another equation, that is w is equal to 1 by 2 into y into pi into 4 pi r square into delta L whole square divided by L by 2. So if I divide both these two equations, what I will be getting is, so or you can say that first of all this equation can be written as this 2 will go in the numerator, so this will be equal to 1 by 2 into y into 8 pi r square into delta L whole square divided by L. So this is the equation number 2, and this is the equation number 1. So by dividing these two equations, I will be getting the value as 1 by w. So this 1 by 2 and 1 by 2 will get cancelled out. Y and y will also get cancelled out. Pi r square and pi r square will also get cancelled out. Delta L square will also get cancelled out, and so eventually I will be left with only 8. I will be left with, sorry, not 8, I will be left with 1 by 8. If I divide these two equations, then 1 upon w will be equal to, so this whole term divided by this term, so this will be equal to this will be equal to 1 by 8, or simply we can say that the work done in the second case will be equal to 8 joule. That is, the work done in stretching the second wire, which is having double the radius and half the length, by 1 mm will be equal to 8 joule. So the correct option is C. So thank you very much for joining this session, and in the next session now I will be discussing about the thermal stresses and strain, and if possible we will be also doing one numerical problem from that topic also. So till then, have a nice day.